In this video, we are continuing with learning target 20. I can use numbers written in scientific notation to express how many times as much one is than the other. So we're going to be looking at comparing scientific notation and how do we take two values with at least one written in scientific notation and comparing it with another value without having to write out the standard form of each of those numbers. So to compare two numbers given in scientific notation, you're first going to compare the exponents. The one with the greater exponent will be greater. However, if the exponents are the same, then you're going to compare the decimals or the significant digits. So if I look at my first example here, I have 2.56 times 10 to the 5th compared to 4.2 times 10 to the negative 7th. So again, the first thing I'm going to do is compare those exponents. So I have 5 compared to negative 7. Well, 5 is greater than negative 7. Therefore, 2.56 times 10 to the 5th is going to be greater than 4.2 times 10 to the negative 7th. In my second example here, I have one value written in scientific notation, but the other one is not. So I'm going to do a quick conversion of this first number into scientific notation so that I can compare them that way. So my decimals at the end, 1, 2, 3. This would be times 10 to the third. So looking at my exponents, I have 10 to the third compared to 10 to the third. Well, 3 compared to 3 is going to be equal. These values are equal because 3 is equal to 3. Looking at my next example, I have 7.8 times 10 to the negative 7th and compared to 7.8 times 10 to the negative 8th. All right, so looking at those exponents, 10 to the negative 7th, 10 to the negative 8th. So negative 7 compared to negative 8, and be careful with your negatives, negative 7 is greater than negative 8. Therefore, 7.8 times 10 to the negative 7th is greater than 7.8 times 10 to the negative 8th. Our last example here, it says put the following numbers in descending order. So that would be from greatest to least. Okay. But notice our numbers are in all different formats. So we have 45%, 4.6 times 10 to the negative second, 1/2, 0.045. So the best recommendation to order these is to get them all into one format. I think decimal tends to be the easiest. However, you can change them all in the scientific notation. You could change them all into percents, but that gets very difficult if you're not super confident in doing that. So 45%, I'm going to change these all to decimals. My scientific notation is small enough that I am able to write my decimal relatively quickly. So 45%, that's 45 out of 100, which is 0.45. 4.6 times 10 to the negative second, I would be moving my decimal 2 places to the left. And that would give me 0.046. 1/2 we know is 0.5, and then I have 0.045. I'm going to fill in some extra zeros here to help me compare, and I see that my smallest number is going to be here, and my greatest number is going to be right above that. So since I'm writing in descending order, my first value is going to be 1/2, because that is my largest decimal. Okay, my second largest value is going to be the 45%. My third value, as we're moving down the line from greatest to least, is going to be 4.6 times 10 to the negative second. And then last, I have 45 thousandths. And that's how you order decimals or values from least to greatest or greatest to least, depending on what the question is asking.